Hi there, thanks for tuning in. This is a little video about the ambiguous case of solving triangles using the law of sines. And in a certain situation, we have some problems. So that's what this video is all about. First off, that word ambiguous is kind of good to look at there. It just means open to having several possible meanings or interpretations. The word equivocal is kind of a synonym for ambiguous. An ambiguous answer. There's not really one answer. There might be two, might be three, might be more. All right, and in a triangle, when we have a certain set of numbers given to us, specifically side angle, all right, that is a problem. Okay, and side angle information, that is ambiguous. So we have to remember that. So when we are trying to find, let's say, the measure of angle B, okay, with the law of sines, we have to consider two possible answers. Either angle B equals some number from our calculator probably, or angle B is 180 degrees minus that number. So that's where the ambiguity comes in. All right, so the three possible situations exist when you are looking at side angle information. All right, those three possibilities are: you might end up with two different triangles and be unable to differentiate between them. You might end up with no triangle at all, that's a possibility, or you might have one unique triangle, which I guess that's the best situation. So we'll do a couple of examples demonstrating how this could come about. All right. So in the first one, our first triangle is that we have two sides given, side, and then the angle not in between those two sides. So side angle. And you have 35 degrees, and the side opposite that is 6, and then we have another side with 8 units. And we should use the law of sines, because that's our only choice, really, to find the measure of angle B. So you set up that proportion there, sine of 35 over 6 equals sine of B over 8. And you work out the algebra there, cross multiplying and dividing. Then you take the inverse sine of that fraction, and you work it out so that angle B is 50 degrees. Okay, so unfortunately, we're not done because we were given side angle information, so we have to also consider that angle B might be 180 minus 50, which is 130 degrees. So those are the two possible choices for angle B. Now, we've already been told that angle A is 35 degrees, so that's okay. We add those up and subtract from 180, and in both cases, we get an actual number. We get either 95 degrees or 15 degrees for angle C. Well, okay, so far we still have two possible triangles. Let's work out the length of side C now with the law of sines. And in the first case, where C is 95 degrees, you set up your proportion, cross multiply, and divide, and you get side C is 10.4 units long. Okay, well that could happen. If you work it out for the other angle, for other measurement for angle C, you'll get side C is now 2.7 units long. And that's also possible. And in fact, without knowing more information about this triangle, we are stuck. We are at a point of ambiguity. We have no way to really determine which triangle is the one, in fact, that we're given. So there's not enough information. This is a case where there are two possible triangles. Not unique, two possible triangles. And that's as far as you can go on that problem, okay? So the next possibility, let's take a look at that. We have side angle information once again, and if we are trying to find the measure of angle B with the law of sines, there's the proportion you would set up, sine of B over 5 equals sine of 45 over 3. You cross multiply, and you take the inverse sine of that, and you get the inverse sine of 1.18, which if you try that on your calculator won't be able to do it. It'll give you an error message, or it might say undefined, some kind of thing like a domain error maybe. It'll tell you in some way or another that that doesn't work. And that is because, my friends, that the sine of an angle is always between -1 and +1. There is no angle that has a sine greater than 1. So the inverse sine of 1.18 just does not exist. All right, so that means that there's no triangle possible with the information that we were given. It just can't work. So the last case, all right, where we have a triangle, side angle information given once again. And if we are trying to find the measure of angle B with the law of sines, that would mean that we would use sine of B over 7 equals sine of 50 over 8. And we cross multiply and we work that out to find the measure of angle B, and we end up with 42 degrees. But once again, we were given side angle, so the other possible measurement for angle B is 138 degrees. That's 180 minus 42. So we have those two possible measurements for angle B. Angle A is 50 degrees, we know that. And so then if we work out angle C, subtracting those sums from 180, of course, we get, in the first case, that angle C would have to be 88 degrees. Okay, well that's possible. But in the second case, look at those two numbers, 50 and 138. If you add those up, you're over 180 degrees. That's 188 degrees, which would mean that angle C is negative 8 degrees. That doesn't work, okay? Angle C is not a negative number in a triangle. So that means that we really, in this case, can eliminate that, and we can proceed with our one unique triangle, okay, to find the measure of side C. We work out the law of sines one more time, and we get 10.4, and so this is where we have just one unique triangle. Okay, so that's good. So that's the three possible situations that can occur when you are given side angle information about a triangle. All right, so just be aware of that, and you might just say that side angle is bad. Okay, all right. Anyway, I hope this was somewhat helpful, and take care.